James Webb just stared at Pluto, and everything we thought we knew shattered in a single night. A frozen corpse of a world, 5 billion kilometers from the sun, suddenly began to glow from the inside out, light where there should be none. Heat rising from ice that hasn't seen warmth in 4 billion years. Stay with me for the next 7 minutes. Because what you're about to hear isn't speculation. It's brand new science straight from the telescope's raw data. Secrets Pluto hid for decades are finally spilling out. And by the end, you'll never look at the edge of our solar system the same way again. Pluto was never supposed to be interesting. When Clyde Tombaugh found it in 1930, it was just a faint dot sliding across photographic plates. Too small, too cold, too far away to matter. Sunlight takes almost 6 hours to crawl out there. The surface temperature hovers around -230 degrees Celsius. For 76 years we treated it like a cosmic afterthought, then quietly kicked it out of the Planet Club in 2006. Dead world. End of story. Except dead worlds don't move. In 2015, New Horizons screamed past at 50,000 kilometers an hour and sent back pictures that made planetary scientists choke on their coffee. Towering mountains of water ice harder than steel. Nitrogen glaciers flowing like toothpaste across heart-shaped plains. And above it all, a delicate blue haze climbing hundreds of kilometers into space. Beautiful, yes, but impossible. That haze should have collapsed long ago. Instead it hung there, perfectly stable, while the thermometer read 40 degrees colder than every supercomputer predicted. Something invisible was stealing Pluto's heat and throwing it away into the void. No one knew how. Fast forward to 2024. A million miles from Earth, the golden mirrors of the James Webb Space Telescope swing toward the most sensitive infrared eyes humanity has ever built toward the Kuiper Belt. A team led by Tanguy Bertrand requests just a few precious hours of telescope time. What comes back isn't an image. It's a heat map. And Pluto is glowing. Not the surface. The atmosphere itself is on fire in mid-infrared, radiating energy like a living thing. Tiny particles of soot-like hydrocarbons, tholins, suspended in that thin nitrogen air are doing something no textbook ever allowed. They re-soaking up the feeble sunlight, converting it directly into infrared, and blasting it out into space. Pluto has invented its own air conditioning system. A self-regulating haze that cools the planet 40 degrees faster than physics said was possible. The dwarf planet isn't just surviving. It's controlling its own climate with chemistry alone. But Webb saw something even stranger. Methane gas is leaking off Pluto in slow motion, drifting toward its largest moon, Charon. Out there in hard vacuum, ultraviolet light from the distant sun rips those methane molecules apart and stitches the pieces into complex red organics that snow gently down onto Charon's poles. That's why Charon wears blood-red skullcaps no one could explain. Two frozen worlds, locked in a gravitational dance, quietly trading the building blocks of life across 19,000 kilometers of darkness. And then the data did something no one was ready for. Deep inside the infrared light curve, temperatures flickered. Tiny pulses, almost like breathing. At first they blamed instrument noise. Then the pattern repeated. Some researchers whisper about micrometeorites peppering the haze. Others, in private, use a different word: cycles. As if the haze itself thickens and collapses on a decades-long heartbeat, driven not by wind, not by storms, but by pure photochemistry under starlight so faint you couldn't read a book by it on Earth. Imagine a weather system with no liquid oceans, no volcanoes, no plate tectonics. Just dust and sunlight running an invisible machine that keeps an entire world alive. If that's real, Pluto just became the first known planet with particle-driven meteorology. And it might not be alone. Titan drifts through Saturn's rings with the same kind of haze. Triton orbits Neptune under an identical veil. Both show the same impossible cooling. Suddenly the coldest, darkest corners of our solar system look less like graveyards and more like laboratories quietly running billion-year experiments in self-sustaining chemistry. Here's the part that keeps planetary scientists awake at night. 4 billion years ago, Earth probably looked exactly like Pluto does today. A hazy orange-brown sky, methane and nitrogen air, continents still molten, no free oxygen yet. The same haze that now cools Pluto might have once shielded our infant world, buying time for the first fragile organics to link up into something that could replicate. We are quite literally staring at a frozen echo of our own origin story. Out there, half in shadow and half in light, Pluto keeps its slow secrets. The blue haze scatters sunlight that left the sun before you woke up this morning. Glaciers creep a few centimeters a year across Sputnik Planitia. Methane drifts to Charon and paints it red. And somewhere in that silent ballet, a dwarf planet no bigger than Australia is rewriting the rules of what a world can be. We once thought life needed a star's warm embrace. Pluto just proved you can thrive on starlight so weak it barely qualifies as a glimmer, if you're clever enough with chemistry. If a dead rock at the edge of space can teach itself how to manage its own temperature, how to feed its moon the molecules of life, how to pulse like it has a heartbeat, then the universe is far more alive than we ever dared to dream. The story isn't over. Webb will watch Pluto again as its 248-year orbit swings it farther from the sun. Will the haze collapse when sunlight weakens even more? Or will it adapt again? Engineers are already sketching new horizons too. An orbiter that could spend years diving through that glowing veil, maybe even touching down on plains where nitrogen snow falls upward in the low gravity. Because Pluto isn't finished with us. It spent a century hiding in plain sight, waiting for eyes sharp enough to see what it really is. Not the end of the solar system. The proof that even in the deepest cold, something still stirs, something still dreams in slow motion. Something is still becoming, and if a forgotten dwarf can do that, what else is waiting out there in the dark, quietly rewriting the laws of possible?